Properties of acids and bases. So first, properties of acids. Acids all contain hydrogen. They taste sour. Some are corrosive to metals. In water, they produce the hydronium ion, which is H3O+, and it's the ion that forms when a water molecule gains a hydrogen ion. In water, they are electrolytes. Indicators change in color in the presence of an acid or base, and they react with bases in neutralization reactions. So some common acids, we have citric acid, which is found in citrus fruits, malic acid, which is found in apples, propanoic acid is used as a preservative, folic acid is found in leafy vegetables and grains, acetylsalicylic acid is found in aspirin, carbonic acid is found in blood with a pH of around 7.4, acetic acid is found in vinegar, oxalic acid is found in spinach, and lactic acid is found in buttermilk. Hydrochloric acid aids in digestion. Muriatic acid is used by masons to clean brick and stone. Nitric acid is used in explosives and fertilizers. Phosphoric acid is used in fertilizers and soft drinks. Sulfuric acid is the #1 chemical produced in the United States. It's used in paints, plastics, fertilizer, and car batteries. And sulfuric acid is a dehydrating agent. That means it takes water out. So some properties of bases. When added to water, it increases the hydroxide ion concentration, which is OH- of the solution. Bases taste bitter and feel slippery. They break down fats and oils. They're used as drain cleaners. In water, they are electrolytes, and they change the color of indicators. So some common bases, sodium hydroxide is used to make soap and is in drain cleaners. Ammonium hydroxide is used in household cleaners like ammonia, Windex, 409 are fantastic. Magnesium hydroxide is used in antacids and laxatives. Aluminum hydroxide is used in antacids and deodorants. And calcium hydroxide is used in antacids, mortar, plastics, and tanning of leather. Okay, so to finish off the video, we're going to talk about naming and writing formulas for acids and bases. And we talked about this earlier in the school year. So there's 3 rules for naming an acid. And it all has to do with the anion. So the first one, we remember, right, if our anion ends in IDE, it's going to take the form hydro plus the stem of the anion plus IC, followed by the word acid. So for example, say we had HBr, and we look at our anion here, and our anion is bromide. And since it ends in IDE, it will be hydrobromic acid. Now the second rule, if our anion ends in ITE, the ending is going to change to OUS. And this is where we get into our oxyacids. So for example, say we had H2SO3. SO3 is sulfite. So it would be sulfurous acid. In the third rule, if our anion ends in ATE, the ending will change to IC. So say we had HNO3, we know this is nitrate. So since it ends in ATE, this will turn into nitric acid. Now, if we had to write the formula for an acid, say we had this. Say we had to write the formula for phosphoric acid. I see my ending is IC, so my anion had to end in ATE, and that would be phosphate. And I know phosphate is PO4, and it has a -3 charge. So we know hydrogen is H, has a +1 charge. Phosphate, PO4, -3. We're going to crisscross our charges. and it will become H3PO4. Now, bases, you're always going to have a metal cation. And that cation can change, it could vary, but the anion is going to stay the same. It's going to be a metal cation and hydroxide. So our anion will always be hydroxide. So for example, say I wanted to create the formula for aluminum hydroxide, we'd have Al plus 3. Hydroxide is OH minus 1. So if I crisscross these charges, it'll be Al parenthesis OH parenthesis 3. And this concludes our video on properties of acids and bases.